Okay, guys, I'm home with a sick kid today, so I am going to create a key for pages 10 and 11, I believe. Yeah, 10 and 11 for your dihybrid. And if you follow this, you'll have no problem on the quiz. I want to make sure that you're able to do these. All right, so the first thing is you need to make sure that you read the problem carefully and you're extracting the correct information from the problem. Because if you get that wrong, then the whole thing is wrong and you're not going to get any credit and you're going to have to retake it. Oh, I think my voice is going too. All right, so the ability to run normally is a dominant trait. Mice with this trait are called running mice with a capital R. The recessive trait causes mice to run in circles and they're called waltzing mice. Hair is also inherited. Black is dominant over brown. For each of these problems, determine the parent genotypes. Okay, this one we're crossing a heterozygous running. So I'm not going to put anything here yet by the gametes. I have to figure out what the genotypes of the parents are. So I'm going to put that up here since I have a little bit of white space. And that's going to be a heterozygous running. Let me make this bigger so we can all see it. Okay, with a heterozygous black mouse. With a homozygous running. So I know that he's capital R. He's homozygous for running and homozygous for his black coat. Okay. So what we have to do for the first parent is we have to figure out what the 4 possible combinations of gametes are going to be. And for that one, we're going to do the FOIL method. So remember FOIL. Oops. And F stands for first. So of this term here, I'm going to take the capital R and the capital B because those are first. Okay, so I'm going to have capital R, capital B as one possible gamete. The other one for FOIL is outer, so capital R, little b. And then the next one, inner, little r, little big B for inner, these two. And then finally, last is little r, little b. Okay, so those are my 4 possible gametes for parent 1. And then parent 2 is very easy because he can only or her can only produce one type of gamete. So I'm going to go ahead and type it out 4 times, but just because on the quiz I want you to fill in all 16 squares because some people will have to, so it's not fair that if... All right, so there's only one possible gamete when you're homozygous at both traits. Okay. If you're heterozygous at both traits, there's 4 possible unique gametes. If you're heterozygous just at one, there's going to be 2 unique gametes. And if you're homozygous at both, then there's only one type of unique gamete. All right, so what we're going to do is put these, go ahead and put them, it doesn't matter which you put where. So, let me see how I want to do this. Yeah, I'm just going to go ahead and put this first parents here. So you might have yours somewhere else. If you might have them onto the side. And then little r, little b. Okay. And then for this parent, there's only one possibility. Okay. So then what you're going to do is you're going to keep your r's together and your b's together. Oops. So I'm just combining them. Trying to be careful that I don't make a mistake. that. So you should see that these are going to be very redundant. But I'm going to go ahead and go through that redundancy for you guys. So again, on the actual test, even though you don't really need to do all these, I'm going to have you fill in all 16. Okay. So actually what I should have done before I did all that, just to try to keep my head clear of what all this is, I should have just looked at these and say, what are those phenotypes going to be? And say that that's going to be running black. And then the next one is going to be running brown. And then the next one is going to be waltzing black. And then the next one's going to be waltzing brown. So now I can go through these all and just do that way. So I am going to highlight using some different colors here. Let me do the running black. If I can highlight those. All right, so I'm going to do all the running blacks in this color here. Probably not the most efficient way to do it, but get the idea. Those are all supposed to be the same color. Okay, these are all going to be running black. These look like they're all running black. And then these look like they're all running black. Oh, this is kind of a boring one, but sometimes typical of what you see. So this is going to be 16, or 100% running black. So if you did that, if you got that for your answer, that is correct. And let me go ahead and post this as a key, or let me take a screenshot of this as a key so I can post that for people to want to go through the whole video. All right. So that was page 10. Let me do page 11. This is the key. Get rid of that color clear. Okay. So this is the key. And heterozygous running, heterozygous black, heterozygous running. Okay, so they're heterozygous for both traits. So I'm just going to use a different color here. So both of my parents are going to be heterozygous for both traits. So it's going to be, that's going to be one parent, and the other one is going to be the same thing. And I want to make sure that you guys try to keep this consistent, use a FOIL method, and then you'll be able to get through it super fast. All right, so first gamete, when I use FOIL first, capital R, capital B. And then the next one is outer, so capital R, little b. And then inner, little r, big B. And then little r, little b, okay? So that's this parent's genotype. And this parent's genotype, or those are the gametes, is the same. So I'm just going to do the same thing. FOIL, I'm going to just go ahead and do it instead of copying and pasting, just to make sure that everybody gets this. Capital R, capital B, outer, capital R, little b, inner, little r, big B, last, little r, little b. Okay. So now what I'm going to do is I am just going to put these in their places on the punnet. Oops, wrong thing that I copied there. Hopefully this will work. Yep, there we go. And then I can stretch that. And I'm just being lazy here. Missed one. Right? How did I miss one of my gametes? Lost one of them. There we go. Okay. So I'm just putting these that we figured out by foil in the correct positions on the punnet. And then I have the same thing. So I'm going to go ahead and format that. Maybe it is easier to do on the computer. All right, so now I'm going to go ahead and fill these in. Homozygous at both. Homozygous at running. Heterozygous at black. Heterozygous at running. Homozygous at black. Heterozygous at both traits. Okay. So then I have homozygous at running, heterozygous at black, homozygous at running, homozygous at brown, heterozygous at running, heterozygous at black, heterozygous at running, homozygous at brown. All right. Getting the hang of this. Heterozygous at running, homozygous at black, heterozygous at running, heterozygous at black. Homozygous at waltzing, homozygous at black. Homozygous at waltzing, homozygous at waltzing, heterozygous at black. And then finally, you got heterozygous at running, heterozygous at black, heterozygous at running, homozygous at brown, homozygous at waltzing, heterozygous at black, and homozygous at waltzing, homozygous at brown. So now that I did all those, again, I should have probably listed my phenotypes first, but I can go ahead and do this now. I just like to do it from this one so I know what the 4 are going to be or what the ones are that they're going to be. So running, black. I like to capitalize my dominant traits, but that you don't have to do that. Running, brown, waltzing, black, waltzing, brown. All right. Now what I'm going to do is I'm going to count up how many that I have that are running black. Let me see if I can do it this way, and I'll just do it this way. Running black, 3, 4, 5, running 6, 7, 8, and 9. So I have 9 running blacks. All right, now I'm going to use blue for the running brown. 1, 2, 3. Okay, I'm going to use this pink for waltzing black. I like doing it that way because then I don't have to look at every one again once I've identified them. But running black, running black, running black. So that's 3. And then finally pick another color for this last waltzing brown. So it's a 9 to 3 to 3 to 1 ratio. And that's all you have to do. You have to figure out what the parents' genotypes are. Figure out what the parents' gametes are. Put that all in the punnet. Put it, fill it all out, count up how many, or figure out what the phenotypes are from what the gametes would be, and then count up how many of them that you each have, and that's it. Easy peasy lemon squeezy. So this is pretty much exactly what the format of the quiz will be. Your individual question will be different than this.